Is a video solution for number 5 for the integration by parts practice problems. So we're taking the integral from -1 to 2/3 of x times the square root of x plus 1 dx. So we're going to set u equal to x and dv equal to the square root of x plus 1. The derivative of u is the derivative of x, which is just dx. It's 1 dx. And now dv, we need to integrate this to find v. So the integral of the square root of x plus 1, remember that's like x plus 1, here I'll write it out, x plus 1 to the 1/2 power. So this is going to be x plus 1, add 1 to that exponent, which will be 3/2, and then we multiply by the reciprocal of that exponent, which is 2/3. Alrighty. Now, the integration by parts formula is u times v minus the integral of v du. So for us, that is x times 2/3 x plus 1 to the 3/2 minus the integral of v, which is 2/3 x plus 1 excuse me, to the 3/2 du, which is just dx. So now I'll simplify this guy just a little bit. So this is 2/3 times x plus 1 to the 3/2 minus, alrighty. So this 2/3 doesn't change, and this x plus 1 won't change, but we add 1 to the exponent. This becomes 5/2. Then we multiply by the reciprocal of that exponent, which is 2/5. And you can double check to make sure that this is right by taking the derivative of this whole thing right here, this 2/5 times 2/3 times x plus 1 to the 5/2, and you'll get this integrand up here. That's how we know we're right. Alright, so now we need to evaluate this whole thing from -1 to 2/3. And this is where the math gets a little bit long. So I think I'll probably just take it up here. Alright, so first, fundamental theorem of calculus. First you plug in 2/3 and then subtract when you plug in 1 for every x. So this is going to be 2/3 times x, which we're replacing with 2/3 right now, times x plus 1, 2/3, plus 1 to the 3/2 minus 2/5 times 2/3 times, I'm going to write this below it, sorry about this, x, which is 2/3, plus 1 to the 5/2. Okay, and that's just when we plug in 2/3. Now we subtract when we plug in -1. But take a look at all these terms when you plug in a -1, specifically at this x plus 1 term. You're going to end up with -1 plus 1, which is 0. 0 to any power is 0. 0 times anything is 0. It's the same case with this term over here, which means when we plug in x equals -1, the whole term equals 0. So I'm just not going to write it here. So let's simplify this. Let's start with this first term. So we got 2/3 times 2/3, which is 4/9 times 2/3 plus 1, which is 1, 2, 3, 4, 5, 5/3 to the 3/2. Okay, I'll write that. So 5/3 to the 3/2 power minus 2 times 2 is 4, 5 times 3 is 15. So this will be 15 times, and then 2/3 plus 1 again is 5/3 to the 5/2 power. Oh boy. Alrighty. Now this is where our rules of exponents come in to help us solve for this. Actually, there's an easier way to do this that I just thought of. Haha. 4/9 times 5/3 to the 3/2 minus, 4/15. We want something, you know what, actually I think let's just simplify this. I think that'll actually be easier. Sorry about that. I thought I was on to something new and then I think it would have been more difficult than just simplifying this. Okay, so we have 4/9. Okay, so when you take something to like a fraction like this, where it's not to the 1/2 or the 1/3, like square root or cube root, this means take it to the power of 3, and then this divide by 2 means take the square root. So what we're going to do is take the square root of both of this numerator and the denominator cubed. So 5 cubed is 125, and then 3 cubed is 27. So I'm just simplifying this 5/3 to the 3/2 to the square root of 125 over 27. And I'm going to do a similar thing over here. So we're ending up with 4/15. 5 to the 5th is 31/25. So this is going to be the square root of 31/25 because that's 5 to the 5th power over 3 to the 5th power, which is 243. We're taking the square root of that fraction. Alrighty, and now we're going to leave this first fraction alone. So we're going to end up with 4/9 times the square root of 125 over 27 minus, so you may have looked ahead at the solutions and noticed that this equals 0. So what we're going to do, we're going to end up finding out that this 4/9 times the square root of 125 over 27 and 4/15 over the square root of 3,125 over 243 are equal terms. So it ends up canceling each other out, and it ends up being 0. But if you want to know how to do the math here, we'll work through it. So this is going to be 4/15. What we want is this fraction, this fraction to look like 125 over 27. So to do that, I'm going to say, all right, well, let's write this as 125 over 27. So 125 times what is 31/25? Well, 125 times 25. I'm not changing the value, just breaking it apart into two different terms here. And then 27 times 9, yes. 27 times 9 equals 243. And now I can break this into two separate square roots. So I'm going to go ahead and erase all of this over here. Alrighty. So now let's bring this up here. Okay, so we're at 4/9 times the square root of 125 over 27 minus 4/15 times, I'm going to pull this square root of 25 over 9. I'm going to pull that and break this apart into two separate square roots. So this is going to be the square root of 25 over 9 times the square root of 125 over 27. So see, now these two square roots are the same, which is what we wanted. Now we can do some simplifying and do 4 over 9 times root 125 over 27. That term hasn't changed in a while. Minus, 4 times square root of 25, 5, over 5 times square root of 9, which is 3, times the square root of 125 over 27. So then we're at 4 over 9 over 125 over 27 minus 4 over 5. That's, well, I guess we just cancel out these 5s first of all. Ooh. Oh, what was my mistake? Where's my mistake? Oh! Ooh, I'm so sorry. This should be 4 over 15, not 4 over 5. It should be 4 over 15, and this should be 15. Okay. So now to reduce this, we can reduce this 5 to a 1 and this 15 to a 3. Where we're left with 4 over 9, because we're left with 4 over 3 times 3, times the square root of 125 over 27. Now these two terms are the same, so this integral is 0. I hope this helps. Email me if you have any further questions.